So I'm going to talk a little bit about digital buildings. The idea is that as the information age continues to expand to all sectors, buildings can become digital as well. The information that was just talked about by Mark is data that's being used to show what the energy use is of the building. Where do you get that data? Well, there's a lot of different places. The utilities have the data in many cases, not all. But one of the things that's growing out there is the green button idea. And the green button idea is a DOE-funded program that provides a common format for downloading data from the utilities so that display programs like Mark just talked about are more effective. So in this case, I'm just showing you where some of those green button activities are already in place. There's certainly a lot more of the country that can be covered. And that's one of the places that we can really grow so that everybody has access to their utility data. So what about smart buildings? We've talked about that. All the previous speakers have talked about that. And in general, we're talking about situational awareness, and the situational awareness can save 20% on the building energy use. And the situational awareness that I'm talking about is not your situational awareness, but your building's situational awareness. How well can your building understand what it needs to do to keep the occupants comfortable? How well can it do it in a very efficient way so that the building can sense where people are at, what they are doing, what they want, and therefore adapt to the people instead of having the people adapt to the building? So how does the building know who's in the building and where they are and who they are and what they want? Well, the thing that everybody now has is a smartphone. And what do smartphones have? They have lots of smarts. They have GPS, they have Wi-Fi, they have situational awareness. That smartphone is always with you. It's your phone. It knows where it's at. It can tell others where it's at. And therefore, as you move around a building, the building can start to understand what you want. What's your favorite temperature? You're walking into a room, and maybe your favorite temperature is 72 degrees, but someone else's is 68 and someone else's is 76. Well, shouldn't that room adapt to you? Don't overheat it, don't overcool it. Make the resident that's in that room comfortable. And that's something that's starting to grow now. This is an app called Crowd Comfort, where it does exactly that. You can use this app on a smartphone to tell the building whether you're hot or cold. And when you tell the building, it then knows who you are and where you are, what time of day it is, and it can record that and over time learn what your preference is. So this is the equivalent of a Nest for residential, except for commercial. You can use that data then to determine what the comfort situation is for different areas of the building for the last several periods, months, weeks, months, years. You can also do something like this, which is within a building, you see that green areas are cooler, the red areas are warmer. The building can adapt to the people that are in that building at the time that they're in those particular rooms, and therefore you're constantly adjusting to the optimum of the people's needs. And if they're not there, don't heat or cool it if you don't need to. So again, that can all happen automatically. And the point is, instead of trying to have a building operator somewhere who's trying to figure out what you want, let the building find out for itself. Similarly, we can use location-based controls to determine how we want the buildings to operate. In this particular case, this diagram just shows a person leaving from their business going back home. And with a location service, as you approach your home, it can determine that you're coming in, that you want the lights on, that you want the garage door open, you want the air conditioning on. Whatever the situation is, you can have it happen automatically. More importantly, when you leave, all that can be shut down. So now, again, you're providing the services that the people want, but you don't provide any more than you need to. You can have that, that smartphone or other device that you're using interact with the house set the thermostat to your desire at the time that you're there. Don't operate it any more than you need to. There was previous discussion about rooftop units, and I think I'm going to reinforce some of that because there's a lot of interest in this. And the reason that there's interest in rooftop units is because they are everywhere. As previously was talked about, something like 60% of all commercial buildings use rooftop units for heating and cooling. And so the analogy here is that I'll talk a little bit about our lighting program. We have a program called One Stop Lighting Program that retrofits commercial buildings with lighting, with high efficiency lighting. And the value, the interesting thing about lighting is that every building has lighting. So you don't have to determine before you get to the building whether or not there is a lighting opportunity in that building. You pretty much know that they have lighting and that they will continue to use lighting. What's the next most ubiquitous piece of large equipment in a commercial building? It's typically rooftop units. And rooftop units have historically been very hard to improve. They purchase them at lowest cost. They put in the most lowest cost and therefore most inefficient rooftop units. And historically, there have been tune-up programs and a lot of other programs that have kind of worked around the edges but really haven't solved that problem. And what's available now, as was spoken about before, is there are some companies that have created products that retrofit these systems, and the retrofit will both adjust for the speed of the fan, maybe the speed of the compressor. They'll do demand-controlled ventilation. They'll have occupancy sensors. They'll be internet connected. You can have all the rooftop units on your building now talking not only to the operator, but talking to each other so that you can schedule appropriately. So in a smaller building in particular, where the rooftop units used to be standalone individual components, they can now be linked together and managed. And when you do that, the energy savings potential is quite large. This is a result of a study that was done by Pacific Northwest National Laboratory showing that in the Minneapolis area, it's 34 to 43% savings potential. You know, it's as high as 60% in some of the warmer areas like LA. CE has been doing a pilot as well, and our report will be coming out soon. But I think what you see here from a P&L study is that, you know, this is a very real type of savings and it's very large. And the question is, how do we get that into the marketplace? Daylighting controls is kind of another area that has a lot of interest. What you see down below here is the glass in this particular space. The lower part has been activated and the upper part has not, to show the difference. Glass can be dynamic. You can put a voltage on it and you can change its transmissivity so that you can have southern glass and have that view and have the value of the glass itself, but not have the overheating during the summer by simply putting a voltage to it. And then the last thing I'll touch on is LEDs. And again, there was a little bit of discussion about that. But one of the things I'll point out is controls, because the digital building is all about data and how you use that data and how you improve the operation of the building while still maintaining the services that you want to provide to the occupants. So in this case, what this shows here is that you have a target illumination that is true for the life of the lamp. But almost all lamps will start out with a higher illumination when you first put them in, when they're brand new, than after a number of hours of operation. They will degrade or depreciate over time. So what if you could include a controller that reduced the power consumption by 40% when you first put this lamp in, and then over time the power consumption goes up to maintain a constant illumination. So now the occupant gets the constant illumination. You get about a 50% power reduction over the life of the lamp by adding those controls. And that is the power of the digital data that you can get out of there, employing electronics within the devices. And what you get as a service to the occupants is exactly what you want, but you don't have to use any more energy than is necessary to provide that service. Thank you.